Hi guys, I hope this is an easy to follow maths video, and the topic today is factor trees. To help with our factor trees, just remember the prime numbers 2, 3, 5 and 7, because what we're going to be doing is breaking numbers up into the multiplication or the product of their primes. So imagine our starting number is 60, we're going to rewrite that in terms of the multiplication of its prime factors. So remember, a factor is a number that will divide into another number. So 60 can be broken up into 2 times 30. 2 is prime, so we underline it, and then we try and break down 30. What prime number divides into 30? Well, because it's even, 2 again. And 2 times what gives me 30, and the answer to that is 15. We underline 2 because that's prime, which means it can't be broken down any further. But 15 can be broken down, and that can be broken down into 3 times 5. And both 3 and 5 are prime, so we underline them. So that now is the end of our factor tree. But the last little bit is to rewrite 60 as the multiplication of, or the product of, its prime factors. So 60 is 2 times 2 times 3 times 5. And we can abbreviate that because 2 times 2 can be written as 2 squared. So it's 2 squared times 3 times 5. And that's expressing 60 as the product of its prime factors. Here's a second example, 180. We can break 180 up, it's an even number, so we can break that up into 2 times 90. 2 is prime, so we underline it. We can now break down 90, 90 is even, into 2 times 45. And we underline the 2 because it's prime. 45 isn't even, so we can't break it up into 2 times something, but we can break it up into 3 times something, 3 times 15, and 3 is prime. 15 isn't prime because that can be broken down into 3 times 5. And we underline both of those, so now we're at the end of our factor tree. The only thing we need to do now is to rewrite 180 as the product or the multiplication of these prime numbers. So that would be 2 times 2 times 3 times 3 times 5. And we can simplify that a little bit because 2 times 2 is 2 squared, 3 times 3 is 3 squared, and then times by 5 on the end. So that is 180 expressed as the product of its prime factors. In our third and final example, I'm just going to show you that you can break your numbers up in different ways, so your factor tree can be different from somebody else's factor tree. Let's look at 210. We can break that down as 2 because it's even times 105, and we underline the 2. 105 can be broken down as 3 times 35, underline the 3, and I'm sure you can see that 35 can be broken up into, that's right, 5 times 7. So we underline those because they're both prime. So 210 is 2 times 3 times 5 times 7. Now, if we'd have done this a different way, which is what we're going to do on the screen now, we'll still get the same answer. It doesn't matter which way we break down the numbers. So, for example, 210 could also have been broken down into 2 times 105, as we did before, but then 105 we could have chosen to break down into 5 times 21, which is different. 5 is underlined, and 21 can be broken down into 3 times 7. But if we look at our final answer, we can still see that 210 can only be written as 2 times 3 times 5 times 7. So it's the same prime numbers multiplied together that give us 210. And that's how we use factor trees to break numbers up into the product or the multiplication of their prime factors.